So as Zach mentioned, we are heavy users and contributors to OpenTelemetry effort. So what I'm going to talk today is how to auto-instrument your Kubernetes application using OpenTelemetry operator. So before we do get into how do we go about auto-instrumenting our applications, let's talk about some of the foundation concepts about OpenTelemetry. So OpenTelemetry is an open standard for your observability signals. And the signals usually include your logs, metrics, and traces. All of us are familiar with logs. Logs are pretty universally used across all the application. Practically every application emits logs. They're useful to understand the application behavior. You need to know what's going on, troubleshoot issues. Super helpful to have logs. Second signal is metrics. Now, metrics is kind of a mixed bag. Most applications, they start without metrics, I would say. And then as they mature, then they see that, okay, we need to add metrics because we are scaling. We need to know how many users are accessing us, what's the request rate, what's the latency, and things like that. So metrics are good to understand overall health of your application. Usually there are units of metrics like counts, gauges, histograms that help us understand the behavior or overall health of your application better. And other good thing about metrics is it helps you create dashboards and alerts. If a request per second exceeds a certain threshold, you can immediately configure an alert to notify you on Slack or email or wherever. Third signal is traces. Now, traces is one of the least used observability signal. And the reason being, for traces to be useful, you need to instrument your entire stack, if you will. Like if you have a microservices architecture where a request comes in, it goes from service A to service B to service C, and if only service A is instrumented, not much useful to have traces there. You need to instrument every microservice for them to be of any value. So that's I would say a blocker, because with microservice architecture, there are different teams, they have different commitments, so not everybody will instrument, or some might instrument little later. So there are all sorts of things going on in terms of team dynamics as well. But once you do that, traces do give you a complete picture of your transactions within your applications. Like you can figure out what is your end-to-end latency for a given transaction. A request comes in, till the response goes back to the user, you will know how much latency or how much delay or how much processing it took. So it's absolutely great once you get there, but the path to get there is painful. And there are things that we can do to improve that path. And how do we do that? So let's dig a little bit more into traces, and then we can see how we can auto-instrument the applications. So OpenTelemetry defines a trace as something that records the path taken by request as they propagate through multi-service architecture like microservices or serverless. So as I mentioned before, a request going from service A to service B to service C is a trace. You can have a trace for that kind of a transaction. And a trace is made up of something called spans. So a request going from one service to another service is a one span. Then then the request going from that service to third service is another span. But all of them were triggered because of the same original request. So that's a trace. So a trace is at the higher level. It can be composed of multiple spans. And as I explained before, traces require your application to be instrumented using your telemetry SDKs. There are two ways to instrument. One is manual and the one is auto. And it also needs all the application to understand the the propagation headers, because when the request is going from a service to service, there are different header formats that are out there, and all of them have to use the same format for them to be useful. When you look at traces, it typically looks something like this. A flame graph is a very common representation of a trace. So here let's say we have 3 services implemented in different languages: Python service, Node service, and Golang service. And the green bar at the top is what starts a trace, and the subsequent bars down are for different services or even for functions within the same service. So color is signifying a service here, and all of these are spans of a parent trace. So that's how you usually picture your traces. And here you can clearly see that how much time did each span take. And going by this, you can see that the orange span took like 114 milliseconds, which is most of the time for your entire trace. So something is going on with that service that you can further optimize. So this gives you an idea where to go about fixing your latency issues if you are seeing such issues. Okay, so now we covered basics of OpenTelemetry. We understood the importance of traces. Let's switch a gear a bit and see what does OpenTelemetry provides for Kubernetes environment. And then we can stitch both of these concepts, traces and OpenTelemetry in Kubernetes together to see how we can auto-instrument. So there are components that OpenTelemetry provides for Kubernetes. Number one component is something called a collector. Most widely used component in the OpenTelemetry ecosystem. Collector is something that you install on your infrastructure, be it like a Linux server or Kubernetes. And what it does is it has a bunch of receivers that you can configure to collect different signals. That it can collect your host metrics like CPU usage, memory usage. It can collect your logs. You can go to a directory like var log and collect all the log files from there and ship it to your backend. And the third thing it can do is also process traces emitted by your applications. So traces is the part that we are going to focus on. And collector is also responsible for shipping traces to your observability backend. The second component in the OpenTelemetry Kubernetes ecosystem, not as widely used as it should be, is the operator. Kubernetes operator in OpenTelemetry is something you install in your Kubernetes infrastructure. And what it allows you to do is it allows you to automatically instrument your Kubernetes pods to collect OpenTelemetry traces. So it has a way to configure something called mutating webhooks in Kubernetes. So when your pod is coming up, the webhook, mutating webhook gets triggered, and it can inject an init container inside the pod before the pod is even operational to configure the auto instrumentation aspect of for that particular pod. And it does it differently for different languages because different languages behave differently when they are operational. Some are compiled, some are scripts like Python. Java is like bytecode. So it does different configuration for different languages. You can read about how it does auto instrumentation all on OpenTelemetry's website. We would not have time to go into detail for each of those. But in a nutshell, when a pod is coming up, it does a language-specific thing to make auto instrumentation happen. So even if you have no code for instrumenting within your application, your traces, your applications are still going to emit traces. Okay, so the third thing it provides is something called instrumentation custom resource. So I mentioned that there are different languages that we can auto instrument, and each of those languages have their own nuances. So we need a place where we can specify if we want to do something custom for a different language, or if we want to ship traces, let's say you have a prod and dev environment, you want to ship your traces for prod to a particular backend, and your dev traces will go to some other backend. So you can have customization when it comes to your instrumentation in this resource. And I'll go into detail a bit more about what this exactly means. I'll show you a sample configuration that will make it more clear. So what are the steps to auto instrument? Install the operator. It's a simple kubectl command on OpenTelemetry's website. Once you install the operator, second thing you need to do is install the collector, or something that will collect all your traces and ship it to your backend. You can either use the native OpenTelemetry collector, or you can use Middleware's Kuberenetes agent, which is a 100% OpenTelemetry compliant collector distribution. If you use Middleware Kubernetes agent, you get your host metrics without any configuration for all your nodes, your cluster. In addition, you can also get some other metrics that official collector does not provide. Like, we can show you what are your volumes, volume claims, roles, cluster role binding, etc., which are not there in Otel collector. So we have taken Otel collector and then extended it to provide more features and more value. So, but you can install either one of them, and traces should work with both. The third thing you need to do is something I mentioned before, is to create an instrumentation resource where you can specify how you want to instrument, auto instrumentation should work for your different languages. Like, let's say you have a Python and you want to export Python traces to this endpoint. In this case, both Python and Go are exporting to the same endpoint, but you could configure them differently to ship them to different endpoints. And there is a bunch of other configuration that I have not shown here that you can do for language-specific instrumentation. The other cool one is the sampler. The sampler says, if you generate 100 traces, how many traces do you want to sample? So one is sample everything, and then you go down to 0. So whatever between 0 to 1 is like a percentage. So if you specify 0.75, then it's going to sample your 75% of trace. It's going to process your 75% of traces and drop your 25% traces. So this is good for sampling if your application is very noisy and generates a lot of traces. So you can sample them. So you can configure propagators. Like, as I mentioned before, that when a trace goes from service A to service B, there are different standards as to what headers are being placed. So you can configure what propagators do you want to use. So in a nutshell, this is kind of your custom instrumentation configuration. If you just create this and leave propagators, samplers, and language as empty, just provide the exporter at the top, it's good enough. It will work. The defaults will take over. But at least you at least need to provide the exporter endpoint. That is a mandatory. But other things are optional. You can skip and the defaults will take over. The fourth and the final step you need to do is simply go through your Kubernetes deployments. Oh. Okay. So fourth and okay. So fourth and the final step is the fun part. You go through your deployments, Kubernetes deployments, and figure out what all the services that you want to instrument. And the way to instrument is just add simple annotation to your deployments, Kubernetes deployments, saying if an application is implemented in Python, just add this instrumentation, add this annotation, and it will start auto-instrumenting the application. So this is the final step. And as you see, there is nothing we did inside the code of an application. This is all happening either within the Kubernetes configuration or OpenTelemetry configuration. So you don't need to change your application at all to generate the traces. How does it work? It's magic, to be honest. But again, there is some OS level changes and application programming language level work that happens. It's too technical to go into details right now. Maybe we can have an offline chat. But at the high level, what happens is when you annotate a deployment to say, hey, auto instrument this pod, what happens is when the pod is coming up, the operator gets a call or a webhook call to say, hey, a certain pod with an annotation is coming up. So it injects an init container, something called an init container in Kubernetes, before the actual container comes up. And that init container overrides a lot of language packages and libraries with the instrumented ones. And that's it. When the container comes up, it sees that, okay, nothing has changed. It continues to run as it is, but the instrumented code is what is actually being used rather than the original packages. So that's how it works at the very high level. And what operator also does is it injects some environment variables inside the pod for you to be better able to, for the instrumentation to be better able to send the telemetry data. Like one thing it does is, remember in the instrumentation configuration, we had an endpoint. So operator injects that endpoint into the pod so that the instrumentation library, auto instrumentation library knows where to ship the traces. So if you were to manually do all this, you would have to configure something like this in your application source code for every application. This example is in Python, but there are SDKs available for every language, and you would have to go and do something like this for all your source code. Versus auto instrumentation, you just add this line and you're good to go. Okay, so I'll quickly go through the architecture. I have already explained most of this architecture here. We have an Otel operator there on the right, who does auto injection of the containers. These two are the pods that are coming up. So each one of them will have an instrumentation container when they would have come up. And then there is an application container that's generating traces because of the instrumentation container running inside the pod. And all of them are coming to your OpenTelemetry collector or Middleware's Kubernetes agent, and then getting shipped to your OpenTelemetry ingestion backend. So Middleware is 100% OpenTelemetry compliant, so we can act as an Otel ingestion backend in this case. Okay, fun time. Demo. So in the demo, I have set up like this. So we have 3 services written in 3 different languages. The first one is a Python service, which talks to a Node.js service, which talks to a Golang service. Now in Golang service, what I have done is I have injected failures. So 40% of the calls will fail for Golang service. And then Python service also does a few SQL queries on a MySQL database. This is all running in Kubernetes cluster. I have load balancer as my service type for Python. So client will send the traffic to load balancer, and load balancer will send to Python. Python will send to node to go, and the reverse will go back. So that's the flow. And I'll show you the source code quickly at the end for these 3 applications, just so that you know that there is no OpenTelemetry code inside any of these programming, in any of this source code, and it still gets auto-instrumented. Okay, so is it better? Okay, so as I mentioned in the picture, there are three services running. and all of these. Yeah. Okay. What happened? Sorry. Okay. So there are three services: Node, Python, and Golang. Okay. So what I'm going to do is trigger a curl request to the load balancer's IP address. And before I do that, let me show, because I'm using middleware as a backend. So let me quickly show you. So in the middleware, if you go to APM, right now we don't see any traces. This is our APM tab. We don't see anything here. No spans, nothing, no services. Now what I'm going to do is run the curl request. I'll run it in a loop. So every 2 seconds, one request is being sent to the load balancer, which is then going to send to Python, to Node, to Golang. And you will see some failures because I have injected the failures in the Golang service, which is the third service. So it's running every 2 seconds. It is making a curl request. And what this will do is it takes few minutes for traces to show up in the middleware. We'll give it couple of minutes. But while this is happening, let me also switch to past 5 minutes. While this is happening, let me show you the source code for these applications. So all the source code, I posted it on GitHub. You can find it in this repository in that Middleware Labs account. So Python service looks something like this. It's a standard standard Flask app, nothing fancy going on here. But key thing to notice is there is no OpenTelemetry instrumentation that is being done here. Same thing for Node and for Golang as well. Yeah, server.js, same thing, nothing fancy, just a simple endpoint. Okay, so same thing for Go. There is no OpenTelemetry SDK is being imported. Okay, so let's go back and refresh. Yeah, we started. Oh, that's visible. That's visible, right? So we started seeing traces coming in. And if you go on the services tab, you can see the 3 services. You can see the Python node and the Golang service and number of requests each one of them got, their latencies and the error rates. So here are the spans that are coming in. So we'll go to a parent span, which in this case is this one, which is the parent span, which triggers all the children spans. So if we open it, oops, the demo gods have open. So I have it here. So I opened a parent span in this case. This picture I displayed it before as well, but the top one, the blue one, is the fetch endpoint, which is the Python service. Then it calls the node service, which is in purple, and the orange one is the Golang service. So as you can see, without any code change in any of the applications, we were able to instrument them and get spans and traces at the backend. Going back to my presentation. Yeah, that's it from me. These are some of the references that I had used for this presentation. And I'm open to any questions that you might have. Yes. Absolutely. Absolutely, you can do that. Yeah. It's just, the one good thing that if you do manual instrumentation is you can do a functional level tracing, because the auto instrumentation is unaware of the functions within your code. So if you're with manual, you do get that. But you can mix and match both. There's no limitation on that side. Because as long as the propagation header is of the same format, like baggage B3, doesn't matter, basically. Yeah. Errors as in, yeah, you can do that. So if your pod A is talking to pod B, you can track the latency there. How much was the latency between for that transaction? Yeah. It's not, it's, the operator itself is very lightweight. It's not doing much. It comes into action only when your pods are coming up or going down. It doesn't always run. So the overhead is almost same as you would overhead of manually instrumenting your applications, which again goes to the next level. How busy are your applications? How many traces are they generating is what defines your overhead. But in itself, auto instrumentation is not, it's not significant.
For those who missed the previous part, I was just talking about myself, so not really important. All right. AI monitoring. So two common use cases. These numbers are all made up, but one is the classic GPT LLM wrappers. I'd say this is probably 90% of the use cases you meet in the wild. This is your old consumer-facing AI app. So every company.ai is probably doing this, right? They're servers that call out to GPT, make decisions, and form the sort of boundaries between the customer, their stuff, and the LLM, right? It's probably like 75% of the YC 23 to 24 companies. Again, don't quote me on that. Then there's the other case of foundational models. These are like the hardcore ones, sort of serving these massive things, what OpenAI is doing. MLOps actually just translates very nicely here. A lot of the same problems with some different ones. Fewer people, but a growing number of people are doing this. There are a lot of really cool open source models out there. So people are actually serving their own. And this ends up being really expensive, right? So training it is horrendously expensive. Although there are cases in which you can do it relatively cheaply. Serving it is expensive, but not quite as expensive. But if you're used to like your standard AWS costs, and then you start seeing like what it takes to run stuff on the GPU in production at scale, you kind of get a little sticker shock. I'll probably talk mostly about the first one, but it'll be relevant for both. Cool. So I want to talk about like 3 levels of monitoring here, 3 things you want to get out of your telemetry system. One is the system behaving well? 2 are the AI components of the system behaving well? And 3 is the output good, like whatever that means, right? And again, this is a similar construct to MLOps. I don't know if any of you are MLOps people, but that's sort of my background. So it, again, translates quite nicely. These are the same tiers of questions that you have. Sort of taking the standard of sort of software DevOps and stuff and sort of extending it out into the more nebulous questions of do the numbers make sense? In this case, does the text make sense? All right. So is the system behaving well? I want to say you all know how to solve this. This is what like OpenTel, Middleware, Honeycomb, all of these tools can solve this quite nicely, right? Obviously, this isn't a solved problem because you keep incrementally making it better. The open standard for telemetry is always improving, but this is also in some way a solved problem, right? It's like there's a sort of good set of standards, and that's why OpenTel is a thing, right? So are the AI components behaving well? This is really taking the space of the things you care about specifically for Gen AI applications and projecting it onto onto the sort of previous question, is the system behaving well? This is really just like, what metrics do you care about and which ones do you want to log, right? Latency, so these are just the ones that people care about, and obviously there are a lot more, and everybody has different things they care about, so. But you're probably familiar with latency, time to first token, throughput, time per output token, so tokens per second. Completion token, just like counting the tokens, prompt tokens, so tokens back is completion tokens, tokens in is prompt tokens. The cost in tokens time the dollar per token, right? Which is a number that a lot of people care about. So then attributes you might want to store in the logs. So you might even get as granular as to store everything, store the input, which is the prompt, the data that goes from the user to the LLM, and the output, which is the response, the data that comes from the LLM back. You also might store a bunch of model parameters. These are basically telling the model how to make their decisions. Temperature, top K, these are just like the ones that OpenAI cares about, and there are a bunch more that other people use. I think people have kind of settled around a standard, but it's moving around too quickly for it to actually be a real standard. All right, and then is the output good, whatever that means? Here's where I'm gonna get a little bit snarky. Because I just have fun. So is the output good? And like, and I have some feelings about generative AI. So is it telling the truth? Probably not. AI doesn't actually know what the truth is, right? It's a tool that can make something that can convince people that it's the truth. But it really just says what is the most probable response, right? Is it making bad decisions? If you let it make decisions, it is quite possible that it will make bad decisions. Is it rambling? Yes. There's like the no yapping trick on ChatGPT. So if you type no yapping, it'll be a much more succinct response. And is it using the wrong tone? ChatGPT is actually pretty good about using the right tone. But this tweet I really liked. It's like, so it's like watching in real time as slop becomes the term of art. The way that spam became the term for unwanted emails. Slop is going in the dictionary as the term for unwanted AI generated content. And this like rings very true. I should have done the other half of this screenshot. But I don't know if you've gotten the new Google that says like, it's just slop. Like it's terrible. Right? Like it's entirely pointless. It says that, then it says the summary from an actual website before. It cites it, and like, it's the type of thing that you read a paragraph and then you're like, this makes sense. And then a second later, you're like, I just lost 3 seconds of my life. So this is the things you're trying to avoid when you're asking the question, is the output good, right? So yeah, I want to say this is an unsolved question, and I welcome people who disagree with me. But anybody who says that it is solved is trying to sell you a solution for that probably doesn't work, right? So here are some common approaches, and this is just a few of them that I've seen. There are a lot of people doing a lot of different things, and there are new papers coming out about this all the time. So yeah, so user feedback for fine-tuning. This is the thumbs up or thumbs down on ChatGPT. AI to evaluate AI. I should have included the exhibit meme, but I might also be dating myself. Yeah, right. And then that's how you just double your cost and also have like nebulous results. One of the companies I'll be talking about came out with a blog post really recently. It was pretty cool about that. A post hoc analysis, tried and true, save all your data somewhere, run stuff on it, run NLP, like whatever you want to like run your machine learning models to have some sense of it. And that could be as simple as just like looking at the words that show up, or more complicated like logging embeddings or NLP tricks or whatever. And then yeah, many other eval strategies. It's just a small sampling. But I think this highlights an interesting point. And you might look at this and be angry because you might think everything's on the right, but I think there's a difference in the way that software is developed. Where in standard software, you gather requirements, build and iterate, get telemetry, and then you improve performance, and you use the telemetry for the improving performance. So then you go back and like make the function faster, right? In AI software, I want to say that there's like one other feedback loop, right? So not only do you also do that because you got to make your thing faster, but also you'll gather requirements, build it, iterate, get telemetry, and use that telemetry itself to improve the product. So the opportunity here is that the telemetry can give you extra insight into the actual product itself, and sort of blurs that line between like DevOps and product that I think has historically been like pretty rigid there. And again, this is very similar to MLOps, right? It's not just does the system work and does it fulfill the spec given to you by a product manager? It's does this system work and does it make your users happy? Which is a much harder thing to answer. So I think that's the sort of interesting difference here and the problem that people are getting at. And that's why I think there's a lot of room for OpenTelemetry in this space. So yeah, how can you leverage Otel for this? What works naturally and what sort of opportunities are there? So yeah, what works naturally? All right, so again, as I mentioned it, the low-hanging fruit is the system behaving well, just like auto-instrument it using Kuberenetes. Clearly that works well, not that many extra lines of code, and you've got the answer to which services are slow, right? I'll talk about a few little caveats later on. Are the AI components behaving well? They actually just shipped a PR for common semantic conventions. This is like 2 weeks ago. And these are just taking some of those metrics and attributes above and putting it into sort of common semantics, so you know, like, oh, here's a tag that makes sense. Here's like a attribute name that makes sense. This is a start. I think there are a few caveats here. Actually, I should have asked Tejas beforehand, like, what happens with really big payloads, like when you're just sending a ton of essays on over. I imagine that most systems can handle that, but it is a caveat that you want to think about. And when you get to multimodal data, if you're sending images, videos, audio, essays, or whatever back, it could get a little weirder. And potentially sensitive data in logs. So if you're a company like character.ai, which I don't know anything about the work they do, but it's just an interesting example for this, you want to make sure that like nobody can access the specific data if you're logging, right? So if you're logging all the prompts in response for post hoc evaluation, you want to make sure that's very locked down and that the only people are like people who are accessed it, and you have a full audit log and everything. And that maybe you only do it with the customer's permission. If you dig in and debug, streaming results are typical. I think most of Otel can solve this quite nicely. And you end up building off into specific APIs. So my problem with this stuff before is that like, they're just like, oh, we'll just take the things that people commonly use, which is the OpenAI API. This stuff's all going to change. Exposing the internals of a foundational model is a step to get people using it, but it's not the end state, right? We don't know what the end state is, but I think it's like a lot of these APIs sort of go right towards that. So now on to the hard one. Is the output good? So a lot of this can be done with data export after the fact and sort of logging on the fly. Right, so you can get the Otel vendor to log your data out to a data warehouse, train a model to understand sort of deviation from what you expect, spot check it by looking at examples. I think that's probably the state of the art for evaluation, is run it through and see what happens. Compute embeddings and calculate drift. If you have some like fancy model that'll work on it, then great, you can do that with all the data you stored. And then yeah, compute and log data on the fly to store. So store embeddings as attributes along with it, stick them in your logs. Log the prompt and response for a real-time view. It can all show up in the traces and attributes, et cetera. Right? Cool. So yeah, opportunities building on top of that. So I think the opportunities really lie in that extra error we had between telemetry and product evaluation and iteration. So some areas that I'm kind of excited about, embedding management. In a way, they're really high dimensional metrics. So they can be really big. So like 1,500 floats that represent some meaning that you can't really tell because it's all like projected onto whatever the LLM is thinking. And there can be quite a few of them. You can track drift, see clustering, stick it into a vector store, search it. These are all things that I think OpenTel vendors could potentially provide to make this type of research and post hoc analysis easier. I didn't even think about like aggregating over embeddings, what that even means. And then state and context tracking. So more than just the prompt, right? Because I think a lot of people are like, oh, like prompt in, prompt out, that's what you look at. But really, to understand the decision that an AI system made at any point, you want to know its memory. So what did the system know, and the state? Can you even like reproduce it from any given point? And I think there's, like, given that Otel can just store so much data and is so like open about what it stores, I think there's chances to do stuff like this. So who's trying this? A few places are doing sort of a specific extension to OpenTelemetry. They called it OpenTelemetry. Traceloop is a company. It's another YC company, I think. Largely built on top of Otel. They have this library OpenTelemetry. Translates sort of common AI constructs to Otel. So just like, is that like custom SDK kind of that then like says, okay, how do we log these metrics? How do we log these? I think especially around traces, right? Because then you can look at it and then like, oh, associate the prompt with it, right? And then it gets stuck as an attribute. There's a certain tag name. It was actually recently copied by 2 different places. So this is, I don't know if you can see it, but there's a bit of snark on this GitHub page that somebody copied, company YLabs copied OpenTelemetry, and they had a bit of an argument about it. They ended up attributing it, so all it's good. And then Arise Phoenix. Arise is an ML monitoring tool. We actually have worked with them in the past. Like worked on their product with their product in the past. But they copied a bit of that OpenTelemetry to sort of add into their things, and they've got trace and embeddings view, and they really love these like crazy 3D visualizations where they project like the 1,500 dimensions into 3 dimensions, view it all, and do some like clustering. I don't really know if that's useful, but it provides a very nice demo. So cool. So in terms of alternatives, like everybody's trying to sell something, just because this is such a crazy space. This diagram is some guy's like his mad landscape machine learning artificial intelligence data. It's like some VC. I think only a part of this is AI visibility, but enough of it is that you're like, okay, this stuff's all crazy, right? There are a lot of people trying to figure out something. So there's the like laying fuse, laying Smith, just basic observability tools. They'll say like, oh, they're like they're similar to open tracing, right? I don't think they're specifically open tracing compatible. And then more prompt management platforms than you can count. So this is my opinion. I think that these will probably move more towards open standards. Probably Otel with some like extra something for AI. I'm presuming that generative AI keeps being the thing for quite a while, and it seems like it's useful enough that it is. I think the problem, though, is that AI devs just move too fast and don't care about actual tech all that much. They're just moving on to the next things. So there's always the people who were building crypto, now they're building AI. In 5 years, they'll be building whatever. And that's sort of the froth. And I think when the froth boils down, you'll be able to find like people who are like who care enough about this and sort of now understand the patterns to bring it in and extend the standards to do like the sort of common computing things. That's what I'm excited about. I'm curious to see what that looks like. Hopefully they incorporate some of my ideas. And I'll probably be involved in some way or another. Who knows? So yeah, so that's the talk on OpenTel and AI. I'm going to talk a little bit about what we're building because it's fun and it is related. So everything we're doing is open source. We have 2 open source libraries. One is called Hamilton. It's a way to standardize data pipelines by representing them as directed acyclic graphs. We've got a bunch of sort of enterprises using it to build data pipelines that just make their data teams more efficient. So it's like unit testable, modular, self-documenting. It's all just sort of the way you write Python code, entirely orchestration agnostic and infrastructure agnostic. You can run it anywhere, part of a web service, part of a infrastructure. Lightweight, pluggable, has all these enterprise needs, and you can log using Otel if you want to. There's sort of all sorts of plugins and hooks. We have a UI that's open source and free that you can use to debug your Hamilton workflows. You can see it's very DAG-based. Then we've got Burr. Burr is all about building better AI agents. Agents being loosely defined as a thing that like does something and then makes a decision of what to do next, right? So it's just an abstraction of the state machine. So we like these sort of primitive abstractions that can represent software nicely. Tracing's included, very like built to be. This was built inspired by open tracing, but obviously there's a bridge between OpenTel and open tracing. It can run anywhere. You can persist, reload, debug, and fork applications from any point, and log using Otel if you want. I think we haven't built that specific piece yet, but there's hooks to make that really easy, and sort of the whole ability to do spans and traces in here that can map quite nicely to the tracing capabilities. So you can get very like specific view of your software. Here's what the visibility system in Burr, that's again open source and free, looks like. So that's that. We'd appreciate a star on Hamilton and Burr if you're interested. Otherwise, feel free to reach out to me. You can find me on LinkedIn or Twitter or whatever. So thanks, folks. Really appreciate it.
And I want to throw out there before I forget that in addition, we have currently, I will talk more about semantic conventions in my talk, but we have a semantic conventions working group in Otel for AI. So come along if you're excited about defining how we'll represent AI in OpenTelemetry. Also, what Elijah could not have predicted, having used the line, anyone who tells you different is selling something, is that my talk is Princess Bride themed. Ever considered piracy? Contributing to OpenTelemetry. So this is a talk if you'd like to contribute to OpenTelemetry, but also if you'd just like to understand how the project works, how we decide what to prioritize in terms of work, because it's obviously a very big scope project with, we're the second largest project in the CNCF and the largest one is Kuberenetes. And we are the second fastest growing project in all of the Linux Foundation, again, after Kubernetes. So it's pretty enormous project. And so I'm going to go into this is how it works, how you know whether things are stable, which can be very important to whether you want to use it in production, and how you can get involved if you'd like. I'm Honeycomb's community manager. I manage our pollinators community. I work with a lot of our DevRels and sort of work on our engagement in general. And I am one of OpenTelemetry's community managers. Been on call so long. Now it's over. I don't know what to do with my life. Okay, I'm gonna blow through. I'm gonna guess that everybody here does know what OpenTelemetry is at this point. So, official definitions is an observability framework and toolkit designed to create and manage your telemetry data, such as traces, metrics, and logs. And the key principles of OpenTelemetry, and these were really important to us when we founded the project. You own the data that you generate. There is no vendor lock-in, and you only have to learn a single set of APIs and conventions. Situation before OpenTelemetry, if you are just getting into the space, was everyone had their own proprietary agent. Switching was really painful. It's a lot like switching your cell phone and a lot like your cell phone bill. Like, oh no, we're going to make it as hard as possible to switch so you don't have to, so you won't want to switch. And everybody kind of decided after a while, this is not so good. It is not good to have customers who are mad at us, actually. And to sort of have calls that are low-key shade. And so folks decided, instead of re-instrumenting code bases with a proprietary agent every time you wanted to switch, we were all going to work together. And just like in The Princess Bride, we're going to get out of the revenge business. We're going to stop being pirates. So we set up with the CNCF. And then we, sorry, now I am laughing at my own talk. This has never happened to me before. So I'm going to go through some of the elements of how OpenTelemetry works. So the basic element of OpenTelemetry is the specification. That's where we started. And the spec decides how Otel manages data. It decides your inputs, how we input data, what we receive, how we output it, where we send it. Semantic conventions is basically how a subgroup of spec that we started after we realized that spec didn't give us enough information. And semantic conventions folks work on vocabulary across languages. So for example, there's the AI group that I already mentioned that is working on what are the things that we need, metrics, traces, logs for AI, how do we define them? And then the language specific working groups will be responsible for implementing those in their languages. Other semantic conventions might include things like basic DevOps concepts like uptime metrics, performance metrics. There's lots of different SemConv groups that you can get engaged in. But these two things are what keeps the project standard across the 20 or so languages we're currently implementing in. Spec and SemConv are a great fit for you if you really like to think about what words mean, if you like to think about use cases, if you like working in multiple languages. Language-specific implementations. Each language has the following components. We have the API and the SDK, and you'll remember Tejas talked about this in his talk when we saw an example of the Kuberenetes operator, which is one of OpenTelemetry's working groups. We have an agent and we have an instrumentation library. And for many languages, but not all, there is an auto instrumentation library that will go ahead and set up your instrumentation for you. And each language implements signals as defined in spec and SemConv, and those are traces, metrics, and logs. And so you can go ahead and take a picture of this slide if you want to, and this is also in the OpenTelemetry documentation, but SemConv is, semantic conventions is actually how you know whether something is stable. It's once all of the conventions have been implemented in a language, we've decided, okay, now this is stable. You can still go ahead and use experimental support for metrics or logs. For example, you see Erlang has experimental support in both. Go has alpha, is still at alpha in logging. You can still go ahead and implement experimental and alpha metrics and logs. In most cases, OpenTelemetry, once we've released it, is not going to change so much. It's going to be a matter of us adding to it so you can go back and add more attributes. Governance and technical committees basically govern the relationship between spec and semantic conventions and the language working groups. So the governance committee is elected. They decide what to implement and like what languages, what groups will have, and technical committee determines how the spec relates to the implementation. So basically what happens sometimes is we write the spec and somebody realizes, oh, well, because of the structure of my language, this doesn't really work here or whatever, or we don't understand as a language working group how to implement this, and we want to learn from another group. Technical committee goes around to all the different groups. They're each responsible for being in a number of groups so that we have a picture of how it's all being implemented. And so that when there are questions of, oh, hey, this definition, the way this works is not actually good enough to tell us how it works in all the languages, then you go back to spec and back to semantic conventions. One more important component and important working group is the OpenTelemetry collector. It sits between your service and your telemetry backend, ingests Prometheus, Jaeger, and OpenTelemetry, and a number of smaller proprietary data types. And so I should have put this first, not gonna lie, but this is the overall map of how things work and how they connect. Basically, things start out in specification. They're responsible for standardizing how we correlate signals, configuration, data processing, exporting. It goes around to semantic conventions, where folks are responsible for defining vocabulary and sort of specific components of OpenTelemetry. Governance committee then decides what languages, what technologies we'll implement, where we will prioritize, and the technical committee brings feedback back from those language SIGs to specification and semantic conventions. Two more important groups, and I'm going to mention these because these are actually great places to get started contributing to OpenTelemetry if you're like, I'm interested in contributing, I'm interested in learning more, I don't know how deeply I want to engage or where I want to engage. The end user SIG collects feedback from end users, or people in their brute squad wagons. It basically also offers Otel education panels. A great way to contribute to the project is whatever language you work in, the working group probably needs feedback, and typically end user will go ahead and do panels on, oh, hey, have you implemented in this language? This language is trying to get to 1.0 to 2.0. Can you give us feedback? And that's also a great way to learn sort of from other users. Communications owns the website, the docs, the blog, and these are great contributions to make if you're just getting started trying to learn about Otel, because you can learn in the process of writing a blog post. You can learn in the process of writing docs for something that doesn't have docs. This is just a list of working groups. I'm going to let those, I feel like probably many of you aren't super interested in contributing to OpenTelemetry, but are interested in knowing how it works, which is cool. But if you are interested in joining a working group, this is kind of the list of working groups that I would recommend. If you're like, I don't know where to start, I don't feel like I definitely want to contribute to a specific language, these are places you can get the lay of the land and places where you can make very general contributions. The OpenTelemetry demo is an application that will burn up your laptop because it's an e-commerce site that runs really badly because we needed to send something interesting, and that's how we got it. So you can build things that break people's computers in OpenTelemetry demo. Spec SIG, we already talked about collector SIG, end user comms, and the maintainers meeting is basically this week in OpenTelemetry, happens every Monday at 9. Anyone is welcome, as anyone is welcome to any of these meetings. And if you want to do something really specific, I'm not going to go through this whole list, but this is pretty much everything we are actively working on. So semantic conventions for LLMs, as Elijah mentioned, the Kubernetes operator, as Tejas went through, and we've got about 15 languages that are currently super actively working and a few other initiatives that are cross-cutting. And that's pretty much my talk. If you want to go get involved, you can find a lot of what I just shared with you on github.com/OpenTelemetry/community. And you can just Google OpenTelemetry community and get taken to that page. And that's where you can find sort of these meetings, the mailing lists, and joining the meetings and the mailing list is a great way to start contributing to OpenTelemetry, because the reality is nobody except the technical committee and the governance committee, who are mostly people who have been contributing since the beginning, understands the scope of the the whole project. Almost nobody is like, I have my head around everything. So it's normal to get involved by joining one small group and kind of contributing there, unlike other open source projects where you might want to be able to run the whole thing or understand the scope. And if you have more questions, you can reach out to me by email, or set up an office hour with any of our DevRel team to talk about OpenTelemetry or observability in general. The DevRel team is not charged with selling you anything. That's not our purpose. We really are like excited to talk to you. Yeah, so questions, what can I do for you? Ed? What is one of the biggest challenges the project is facing? I think a big challenge is that we have scaled so fast. OpenTelemetry was formed from a merger of OpenTracing and OpenCensus at the beginning of the pandemic. So it's really only 4 years old, and we've experienced phenomenal growth because everybody kind of realized, oh, it is time for us to jump on this train. And the vendors who didn't jump on the train initially realized, oh yeah, everyone else is on this train. Maybe I ought to get on the train as well. So a big problem is scaling. Another big problem is, the focus of this talk is really how do all of these various pieces, these different languages work together. Most open source projects don't have the scope that we do. They work in one language. They work on, Kubernetes is building containers, and Kubernetes is something you can launch and run and spin up a container. It's very, even a project that big is like a very concrete thing. And OpenTelemetry, it's like we're everywhere. We're in every piece of code. So how do we decide like what the scope is for us to work on, and how do we make sure we don't grow so fast as to mean that we're providing a bad experience for folks because every language is so different? What else can I answer? Yeah? That's my favorite Princess Bride quote. You know, of course, my brain has now gone blank because I've been looking at like pages that are like top 30 Princess Bride quotes, trying to find images. Favorite characters easier. I am really a fan of Inigo Montoya. Favorite. There's one right. Okay, what's your right answer? Hello, my name is Inigo Montoya. Prepare to die. I mean, that never hurt anybody. I like anyone who tells you different is selling something. And I like the fact that that quote begins with life is pain, actually. I think what I enjoyed about putting together a Princess Bride talk is it genuinely, like, I've been in the space a little bit longer than when OpenTelemetry started, and things were genuinely very almost brutal among vendors, like, and everybody was like, lots of people were super unhappy with their telemetry solution, but the cost of switching was just super annoying. So it's exciting to me that we're building a future together, and that, you know, this meetup, Honeycomb is the biggest company at this meetup, which is unusual. Lots of times I'm speaking at meetups with lots of APM folks. who are just these enormous companies, and we're the tiny company. But it's exciting that Honeycomb and companies like Middleware and DAG, they're coming up behind us doing observability, that we can have like more friendly relationships. We have a common goal to work on, promoting the idea of observability, building OpenTelemetry, and we're really able to change the tenor of the space. Somebody in the back has a question. Mm-hmm. I bring him the mic because. Okay, cool. Every point he is making is great and is definitely stuff that we've grappled with in the project. As a matter of fact, I have a whole talk for open source conferences on this exact problem. He's asked, how do we avoid having many people can't get paid for their engagement in OpenTelemetry. It's not something you can run, so there's not a direct profit motive, although I would differ a little on OpenTelemetry, but a standard is not something you can run. And it's not, and so how do you avoid folks who have big amounts of money, big companies, being able to sort of steer the ship? And yeah, we grapple with all these things. One reason that we have this elaborate process I described, and now I've realized I should go back and add a slide that explains why this is here, is that we wanted to avoid having people be able to dictate. So every company can only have